NMB cable, also known as non-metallic sheath cable, is commonly used in residential wiring. However, its use is restricted by building codes based on the height of the building. Typically, NMB cable is permitted in 1 and 2 family dwellings. The key restriction relates to the number of floors. In many jurisdictions, NMB cable is allowed in residential buildings up to a maximum of 2 floors. This means that in a typical house with a ground floor and a second floor, NMB cable can be used for wiring throughout the entire structure. However, once a building exceeds 2 floors, such as a 3-story house or an apartment building with more than 2 stories, NMB cable may no longer be permitted for general wiring. The reason for this limitation is primarily due to fire safety concerns. In taller buildings, there is a greater risk of fire spread, and the materials used for wiring need to have enhanced fire-resistant properties. NMB cable has a non-metallic jacket which can contribute to the spread of fire under certain conditions. Consequently, building codes often require the use of more robust wiring methods in taller buildings such as metal-clad cable or wiring and conduit, which provide better fire protection. It is crucial to consult your local electrical codes and regulations to determine the specific requirements for your area. Electrical codes vary from one jurisdiction to another, and there may be local amendments or interpretations that affect the use of NMB cable. For example, some jurisdictions may allow NMB cable in 3-story buildings if certain fire-stopping measures are implemented, while others may strictly prohibit it. To ensure compliance with electrical codes, it is always best to consult with a qualified electrician or electrical inspector. They can provide guidance on the appropriate wiring methods for your specific project and ensure that all installations meet the required safety standards. When working with electrical wiring, it is essential to prioritize safety. Always disconnect the power supply before working on any electrical circuits. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Improper wiring can create a fire hazard or electrical shock hazard, which can have serious consequences. Remember that electrical codes are designed to protect people and property from electrical hazards. By following the codes and using appropriate wiring methods, you can ensure the safety of your electrical installations. To elaborate further on the restrictions and considerations surrounding the use of NMB cable, it is helpful to examine the specific requirements outlined in the National Electrical Code, or NEC. The NEC is a widely adopted standard for electrical installations in the United States, and it provides detailed guidelines on the use of various wiring methods. While the NEC itself does not explicitly state a maximum floor level for NMB cable in all residential applications, it does provide specific rules that indirectly limit its use in taller buildings. Firstly, the NEC specifies that NMB cable must be protected from physical damage. In areas where the cable is exposed to damage, it must be installed in conduit or protected by other means. In taller buildings, where there is a greater likelihood of physical damage due to increased activity and construction, the use of NMB cable may become impractical or require extensive protection measures, making other wiring methods more suitable. Secondly, the NEC addresses the issue of fire resistance in buildings. It requires that wiring methods used in fire-rated assemblies, such as walls and floors that are designed to contain a fire for a certain period, must maintain the fire rating of the assembly. NMB cable, with its non-metallic jacket, may not be suitable for use in fire-rated assemblies unless it is installed in a manner that preserves the fire rating. This can involve using specialized fire-rated boxes and fittings or encasing the cable in concrete or other fire-resistant materials. In taller buildings, where fire resistance is a critical safety consideration, the use of NMB cable may be limited to areas that do not require fire-rated construction. Thirdly, the NEC provides guidelines on the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry. The ampacity of NMB cable is affected by several factors, including the size of the conductors, the type of insulation, and the ambient temperature. In taller buildings, where there may be longer wire runs and higher electrical loads, it is important to ensure that the NMB cable is properly sized to handle the anticipated current. If the cable is undersized, it can overheat and create a fire hazard. In some cases, it may be necessary to use larger conductors or a different wiring method with a higher ampacity rating. To summarize, the use of NMB cable in residential buildings is subject to certain restrictions based on the height of the building and other factors. While the NEC does not explicitly state a maximum floor level for NMB cable in all cases, it does provide rules that indirectly limit its use in taller buildings due to concerns about physical damage, fire resistance, and ampacity. Always consult your local electrical codes and regulations and consult with a qualified electrician or electrical inspector to ensure that your electrical installations are safe and compliant. Additional considerations often come into play when dealing with specific local amendments to the NEC. Many jurisdictions adopt the NEC as a baseline but then introduce their own modifications to address unique regional needs or safety concerns. These amendments can further restrict or, in some cases, slightly expand the allowable uses of NMB cable. Firstly, some local codes may impose stricter limitations on the types of buildings where NMB cable can be used. For instance, a municipality might prohibit NMB cable in any building exceeding 2 stories, regardless of whether it is a single-family dwelling or a multi-unit apartment complex. This type of amendment is typically driven by a desire to enhance fire safety and may be influenced by local fire department recommendations or historical fire incidents. Secondly, local amendments may introduce specific requirements for fire stopping when NMB cable is used in certain types of construction. Fire stopping involves sealing any openings or penetrations in walls, floors, and ceilings to prevent the spread of fire and smoke. When an NMB cable passes through these fire-rated barriers, it is essential to ensure that the openings are properly sealed with fire-resistant materials. Local codes may specify the types of fire-stopping materials that are acceptable and the methods for installation. Thirdly, some jurisdictions may have specific requirements for the protection of NMB cable in areas subject to physical damage. This could include requiring the cable to be installed in conduit or protected by metal plates in areas where it is likely to be struck or damaged by tools, equipment, or other objects. These requirements are intended to prevent damage to the cable insulation, which could lead to electrical shorts or fire hazards. It is crucial to be aware of any local amendments to the NEC that apply in your area. These amendments can have a significant impact on the types of wiring methods that are permitted and the specific requirements for installation. You can typically find information about local amendments by contacting your local building department or electrical inspection agency. They can provide you with copies of the local codes and regulations and answer any questions you may have about the use of NMB cable. In addition to complying with electrical codes, it is also important to follow best practices for electrical safety. This includes using the correct tools and equipment, wearing appropriate personal protective equipment, and taking precautions to prevent electrical shock. Never work on live electrical circuits unless you are a qualified electrician and have taken all necessary safety precautions. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. Remember that electrical safety is everyone's responsibility. By following electrical codes, best practices, and common sense, you can help prevent electrical accidents and protect yourself and others from harm. Moreover, understanding the nuances between different types of NMB cable is also vital for ensuring safe and compliant installations. The B in NMB signifies an important upgrade in the cable's heat resistance rating. NMB cable is rated for 90 degrees Celsius or 194 degrees Fahrenheit in dry locations, whereas older NM cable had a lower temperature rating. This higher temperature rating allows NMB cable to handle high current loads and operate safely in warmer environments, which is a significant advantage. Firstly, the 90 degrees Celsius rating applies only to the conductors within the cable. The overall temperature rating of the cable assembly may be lower due to the limitations of the outer jacket material. It is important to check the cable markings and specifications to determine the overall temperature rating of the cable. Secondly, even though an NMB cable is rated for 90 degrees Celsius, the NEC typically requires that it be used at the 60 degrees Celsius ampacity for circuits rated 100 amps or less, using number 14 American wire gauge to number 10 American wire gauge conductors. This is to ensure that the connections at the circuit breaker and other devices do not overheat. For larger conductors and higher amperage circuits, the 75 degrees Celsius ampacity may be permitted. Thirdly, NMB cable is available in various sizes ranging from number 14 American wire gauge to number 2 American wire gauge. The appropriate size of cable to use depends on the amperage of the circuit and the length of the wire run. It is important to consult the NEC ampacity tables to determine the correct cable size for your application. In addition to the temperature rating and size, there are also different types of NMB cable available, such as NMB with ground and NMB without ground. NMB with ground includes a separate grounding conductor, which is required for most electrical circuits. NMB without ground is typically used for replacing existing wiring in older homes where a grounding conductor is not available. When working with NMB cable, it is important to follow proper installation techniques. This includes using the correct connectors and fittings, securing the cable properly, and avoiding sharp bends or kinks in the cable. It is also important to protect the cable from physical damage, such as by running it through conduit in exposed locations. Remember that NMB cable is not suitable for all applications. It should not be used in wet or damp locations, such as bathrooms or kitchens, unless it is specifically listed for that purpose. It should also not be used in direct burial applications or in underground conduit. In these situations, other types of cable, such as UF cable or THHN wire and conduit, should be used. Understanding the different types of NMB cable and their limitations is essential for ensuring safe and compliant electrical installations. Always consult the NEC and your local electrical codes to determine the appropriate cable to use for your specific application. Furthermore, the practical implications of floor height restrictions on NMB cable usage extend beyond simple code compliance. They significantly affect the design and cost of electrical systems in residential buildings. Firstly, when a building exceeds the allowable height for NMB cable, alternative wiring methods must be employed. The most common alternatives are metal-clad cable, also known as MC cable, and individual conductors installed in conduit. MC cable consists of insulated conductors encased in a flexible metal sheath, providing enhanced protection against physical damage and fire. Conduit systems involve running individual wires through rigid or flexible metal or plastic tubes, offering superior protection and allowing for easy replacement or upgrades of wiring in the future. Secondly, the cost of alternative wiring methods can be significantly higher than that of NMB cable. MC cable typically costs more per foot than NMB cable, and the installation of conduit systems requires additional labor and materials. This can add a substantial amount to the overall cost of the electrical system, especially in larger buildings. Thirdly, the design of the electrical system must be carefully considered when using alternative wiring methods. MC cable and conduit systems require different types of connectors and fittings than NMB cable, and the routing of the wiring may need to be adjusted to accommodate the physical characteristics of these materials. In addition, the ampacity of the conductors must be carefully calculated to ensure that they can handle the anticipated electrical loads. The transition from NMB cable to alternative wiring methods often occurs at a specific point in the building, such as the second floor ceiling in a 3-story house. This transition point must be carefully planned to ensure a smooth and seamless connection between the two wiring systems. It is important to use appropriate transition fittings and to follow all applicable codes and standards. In some cases, it may be possible to use NMB cable for certain portions of the electrical system in a building that exceeds the allowable height, such as for wiring within individual apartments or for low-voltage circuits. However, this must be done in accordance with all applicable codes and regulations, and it is important to ensure that the NMB cable is properly protected from physical damage and fire. The decision to use an NB cable in a building that exceeds the allowable height should be made in consultation with a qualified electrician or electrical engineer. They can assess the specific requirements of the project and provide guidance on the most appropriate wiring methods to use. In addition to the cost and design considerations, it is also important to consider the long-term implications of using alternative wiring methods. MC cable and conduit systems are generally more durable and long-lasting than NMB cable, and they may require less maintenance over time. This can offset the higher initial cost in the long run. The choice of wiring method should be based on a careful assessment of all relevant factors, including cost, design, safety, and long-term performance. By carefully considering these factors, you can ensure that the electrical system in your residential building is safe, reliable, and compliant with all applicable codes and regulations.